Operating in saturation, we're asked which of the following is true. We've looked at previous questions with BJTs previously, but here we are looking at saturation. This is going to be looked at page 110. So looking at page 110, we have our BJT operates in saturation here, and this is in our bipolar junction transistor notes that are in the description below the like button. So starting here, saturation region of operation, we have this diagram. If both the base emitter and base collector PN junctions are forward biased, then the BJT is in saturation. This is similar to the triode region of operation for MOSFETs. The BJT, this is what that should be, must be forward biased by about 0.4 before our IC and beta drop off. So the edge of saturation is typically assumed to be when our VC is about 0.3 volts. In the forward active region, both beta and our R0 are higher. In saturation, both beta and our R0, which is equal to 1 over slope, are much lower. So forward active, beta and R0 are lower. And then after saturation, in saturation, beta or they're higher beforehand, and then in saturation, they're much lower. It's not a good idea to operate the amplifiers in here since our beta is so low. In saturation, beta is then often referred to as the forced beta. So looking at our question here, the base collector junction can be forward biased about 200 millivolts before the collector current starts to decrease. Well, for the millivolts, it doesn't really say anything here. It does have a 0.2 volts right here, and it's saying the base collector can be forward biased by about 200 millivolts. Well, before it's decreasing. After 0.2 volts, which is the millivolts, we can see that we're increasing. So this would be false because this should be increasing, not decreasing. The common emitter current gain, beta, is much larger than in the forward active region. And we know right here that in saturation, beta is much lower. So this one is going to be false also because it should be lower. The collector current increases linearly as the base current is increased. So if we look at this, our current IC is not increasing linearly in saturation. So operating in saturation, collector current increases linearly is untrue because at saturation, we can see it tapers off a little bit. In here, it would increase more linearly, but not so much in saturation. So this is going to be false. The collector current does not increase linearly as the base current is increased. The output resistance R0 is much smaller than in the forward active region. This is true. In saturation, both our beta and our R0 are much lower. So that means the answer to this problem is going to be D. Not all of these either. That cannot be a solution since only one is correct. So that's how you would use the notes link below the like button to solve this problem.